bivariate data with two variables, and we look at the dependent variable, which is also it's also referred to response variable, RV, which is the y-axis, and we look at the independent variable, which is the explanatory variable, which is the x-axis. So if you look at this example here, the speed of typing and the number of hours spent typing. So the explanatory variable, which is the x-axis, is number of hours spent on typing, and the response variable is the speed of typing. So in other words, the y-axis. All right, now displaying data. So the first stage is to gather the information. The second stage is to classify the type of data we're dealing with. And obviously, after collecting an information, it needs to be displayed. Based on the type of data we're dealing with, there are various ways of displaying data. One is the stem and leaf, histogram, two-way table, or the frequency table, box plot, dot plot, frequency table and the contingency table, quite similar, segmented bar chart, scatter plot. Those are the type of things, the type of displays we could use when we are communicating when we're displaying data, in other words. So depending on the type of data, so there are different ways. So displaying a categorical data, we use a frequency table or the contingency table, or we could use bar chart or segmented bar chart. And also, after displaying, we also need to describe. One of the key features that we are looking for categorical data is the mode. So that is the one we actually need to describe when we are looking at a frequency table or segmented bar charts. For a numerical data, we could use a stem and leaf plot, a histogram, and a scatter plot, box plot, dot plot. Those are the different ways we could use. If the data we're dealing with is numerical and categorical, so we could use parallel dot plots, or we could use a box plot, or back-to-back stem and leaf plot. All right. Stem and leaf plots are used to display data for up to 50 observations. So if the data is big, so we use stem and leaf. And also, to get fair bit of idea of how the shape should look like, because describing a stem and leaf plot, we need to have a clear shape. And if the data is clustered in one area, if most of the data is in one location, so it's better to halve it or split. I made a video on how to split a stem and leaf plot. Please make sure you watch that. Splitting a stem and leaf plot. We could halve it, or we could make it into fifths, which is 0 to 1, 2 to 3, 4 to 5, 6 to 7, and 8 to 9. So please watch how to split that, because I made a separate video on how to split when the data is clustered, just to get a clear idea of how the shape. So now we've dealt with displaying the data. So the third stage, or the last stage, is to describe. So whenever we're describing an association between parallel box plots or histogram, dot plot, stem and leaf plots, we use the shape. So the shape, whether it's symmetrical or skewed, and to know whether it's positively skewed or negatively skewed. So let's say the data, so it's finishing, or it's trailing towards the right hand side. So this is positively skewed. So it's finishing towards your right hand side. If it's finishing towards your left hand side, that's negatively skewed. So if it's this, more of that. So it's finishing towards the left-hand side. The left-hand side, this is negatively skewed. So that is for a histogram. And for a box plot, you look at where the median is. If the median is towards the left-hand side, so that's positively skewed. Alright, so now if it's a stem and leaf plot, just to get a clear idea of how the shape should look like, if most of the data is at the top, so that is positively skewed. So this is the leaf side, and that's the stem side. And most of the values at the top, yeah, it's just sort of finishing off this way, so that's going to be positively skewed. And vice versa. Alright, now describing, we use the shape, that whether it's symmetrical. If it's symmetrical, so most of the values will be in the middle. So it's going to be something, let's say histogram. It's going to be more of this. So it's more of that. So that is symmetrical. So the shape, the spread, the IQR, quartile range, which is Q3 minus Q1. The range, maximum minus minimum value, standard deviation. So the center, we use the median if the data is skewed to describe. So we use those three, so the shape, spread, and center. And when the data is skewed, you use the median. Or if the data has got an outlier, use the median. Alright. Describing a scatter plot, we use the direction, whether it's positive. Let's say we have got a scatter plot here. Let's say temperature and time of the day. So let's say we have got a scatter plot, something similar to looks like this. So put a line. So most of the values are actually going up. So that is positive. And the form is either linear or non-linear. So positive, so linear going straight. The strength can either be weak, moderate, or strong. Strong, so that's going to be linear, strong, positive. Linear, strong, positive. That's how you describe linear, strong, positive. And that's it for displaying and describing data.